All right, so today we're going to start talking about molecular compounds. They're the other type of compound that we haven't really touched on too much yet. The last couple days we've been talking about ionic compounds, something formed between a metal and a nonmetal. Now, molecular compounds, however, are made of just nonmetals. So they're going to come in on this side of the periodic table. Uh, Again, it's going to be two nonmetals. It's just going to be two things from the right side of the step. The next thing we want to keep in mind is that there are no ions, so charges don't matter. All right, so you're not going to be worrying about having to balance out your charges. You're not going to have to worry about figuring out what charge each element is. We're going to go through what you have to do in these cases in a couple minutes. But the last thing I want to talk about is that electrons are shared in this case. So in ionic, electrons are transferred, right? We talked about them going to one thing. One lost the electrons, one gained the electrons. And in molecular compounds, they're actually just shared between the two. You know, neither gets a competitive edge on the other. They're just shared between the two. All right, so when we name molecular compounds, the first thing we want to do is write the name of the first element. So for example, if we had something like carbon, right, we're going to write carbon. And then here's the weird thing, we're going to talk about prefixes. If there is more than one, right, so however many, we use a prefix to say how many carbons there is. If there's only one, you just leave it as its name. We just don't tend to use the prefix mono. Something with the prefix mono on the first element just kind of looks weird. So if you only have one, you can just leave it as is. So you would have some prefix if there's more than one, so 2 to 10, you'll have a prefix, but if there's only one, you just leave the first element blank. All right. On the second element, same thing that we did with ionic. You're going to name, take the ending, so let's say it was oxygen, right? You're going to change that to oxide, all right? And in this case, you have to add a prefix regardless of however many you have. So the prefix is going to come in, just saying however many you have, whatever number it is you have. So let's talk about the prefixes. So first off is going to be mono is for 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta 7, octa 8, nona is 9, and deca is 10. I would recommend writing these somewhere on your periodic table. That way you have them at your disposal at all times. All right, so let's try this out. So here we're looking at the compound CO2, right? First thing we're going to do is name the first element. So that first one's C. You'd go to your periodic table, you'd say, okay, that's carbon. Now, if there was more than one of the carbons, we would need a prefix on it. However, there is only one, so we can just leave that blank. Next, we're going to figure out what our next element is, right? We have oxygen here. Remember, oxygen changes and becomes oxide. However, we have two of them, so we're going to need a prefix here. Remember that 2, the prefix is di. So we say this is carbon dioxide. All right, so carbon, 1 carbon, dioxide, 2 oxygens, right? So prefixes really are just naming however many there are. And when it comes to molecular compounds, what we're really doing is just naming out how many of each element we have. They're relatively straightforward. They're just saying, okay, you have this many of this element, this many of that element. All right, last but not least, we have C3H8, right? So first thing we need to do, figure out what the element C is. Again, earlier we said that was carbon. However, there's 3 in this case, so we're going to need a prefix. The prefix for 3 was tri, right? So this becomes tricarbon. And we have the element hydrogen. Hydrogen becomes, I'm going to leave a little bit more space. Hydrogen becomes hydride. All right, and there's 8, so 8 is octa. So we're going to write octa hydride on there. So our compound here, C3H8, would be tricarbon octahydride. 3 carbons, 8 hydrogens. All right, so really they're just taking a name or taking a formula, counting up however many of each there are, and putting that into words. So tricarbon tells us 3 carbons, octahydride says 8 hydrogens. All right, if you have any questions,